What's going on, you guys? Welcome back to the channel. In today's video, I am super excited to be bringing you a first introduction to Unity and game development. This video features Game Developer Southpaw Development, who, in addition to being my younger brother, is also a degreed, college-educated game developer and computer scientist. And in my opinion, it was really cool to see just how much we were able to build in under an hour from never having built a Unity project before. I previously did an interview with my brother about entering game development, his personal journey to get there, and I encourage you guys to go watch that if you're curious on a little bit of his backstory. And he does have his own YouTube channel as well, so be sure to check out Southpaw Development. It'll be linked below and somewhere in the video right now. And without any further ado, guys, enjoy the tutorial. Thanks for watching, and let me know in the comments below if you like this kind of content, because in addition to featuring his tutorials on my channel, it might encourage him to actually make content for his channel, because between you and me, he's kind of lazy. So without any further ado, here's Game Developer Southpaw Development with an introduction to Unity building your first game platformer tutorial.
Hi there, I'm George, less commonly known as Southpaw Development. You can just call me the better-looking Lemaster brother. I'm coming to you today in a partnership with Lemaster Tech, who has a slightly larger audience than I do, to show you my expertise in a tutorial in Unity. All jokes aside, this is going to be a very basic starter tutorial. I will go through familiarizing yourself with an IDE and with the Unity game engine, and then coding a very simple platformer. Now, this tutorial will be going off of the assumption that you have Unity installed and you have an IDE existing already, something like Visual Studio Code. If you don't, there are lots of videos that could do a much better job explaining it than I can already on the internet. But if you don't feel like looking at those videos, you really don't have to. Just go to Unity's website, download the latest version, and go to some IDE website. Like I said, I recommend Visual Studio, and download that. From there, the installation should be fairly self-explanatory. But assuming you have that, let's move into the tutorial. Now that we have an IDE and the Unity Hub installed, we're ready to start a new project. Click New Project, and it'll take you to a screen where you can select whatever package you want to build it with, as well as some more details like the project name and the location. Now, for our purposes here today, most of these are unimportant, but the interesting thing about Unity is that it runs in a 3D engine at all times, regardless if you set it up with the 2D or the 3D core. With that said, it is easier to create a 2D game inside of the 3D core instead of a 3D game inside the 2D core. So I'll be selecting 3D core for today, and if you want to make a purely two-dimensional project, I'll explain how to do that, because most of the math is the exact same without including the z-axis. You can name the project whatever you want. I'm going to call mine Side Scroller, and select a location for it. In this case, I have it set up to a folder with all of my Unity projects. The organization tab doesn't matter as much. This will usually just be filed under whatever you made your Unity ID. Unity Cloud is really more for its services, and Unity Version Control is sort of like GitHub. But if you're going to use version control, I'd recommend just using GitHub, because Unity Version Control, as it says right here, is new and therefore very buggy. With all that out of the way, you hit Create Project. It'll usually take a couple minutes to load, so I'm going to skip ahead till this is fully initialized. Alright, here we are in a blank Unity project. Yours should look something like this, but there's a chance that you'll have a different layout than I do. If you have a different layout or want a different layout, up here in the top right corner, you can select any number of layouts. Here you can see I've made a couple custom ones, and there's also the ones that come with it by default. For example, 4-split gives you a screen that looks like this. Most of these packages offer more than you'll need for a general game, so I tend to just go with 2 to 3 split or default, depending on which you prefer. I prefer default, so that's what we're going to go with for the project. If you go up here and hit this drop-down arrow, it'll expand everything that's currently in your scene. Now, your scene is essentially the game world. In the same way that the C languages are object-oriented programming, game development is very much so object-oriented. Every object in your game is either going to be in your assets waiting to be called in, or in the game world already. As you can see, all we have right now is a skybox, a light source, which is a directional light, meaning it pretty much illuminates everything universally, and a camera. And as you can see, if we press play, we have nothing. But this is actually the view from our camera right here. Since we have it selected, all of its information is showing up over here. And you can see if we rotate it, our view changes, because that image we're seeing is just the skybox. Also, something some of you may notice right there, but is very important for working in Unity, any changes you make while in play mode, while the application is running, will not exist after you stop play mode. For example, if I set this camera at some crazy rotation and I stop the application, it stops working. All of the changes you made revert to what they were before the scene started. I have lost hours of work because I was in play mode without realizing it, and unless you're careful, you'll make the same mistake. Now, as with most tools, there's lots of options that are presented to us right off the start. Most of them are not necessary to us right now. All you really need to know are these main 4 panels. We already covered the scene view and the game view, which is where you'll see most of the stuff and interact with the stuff in your game. Over here we have the hierarchy, which contains every object in our game world. The inspector, which shows us details about any object we currently have selected. Every object in the world has a transform, but from there it varies depending on what kind of object it is. And down here we have the project window. Right now all it has is a scene folder, which contains our scenes. Every one of these is a scene. And our console, which many of you will be familiar with. Now, this doesn't work quite like a terminal where you can put commands into it. However, this will display any errors that you get while running or compiling your code, and you can also print out messages to here to confirm your code is working and for the sake of debugging. That's the general setup of Unity. Let's get into the actual project. There's lots of ways to start, but what I like to do first is to create some general empty objects just for the sake of organization. You want to right-click inside of the hierarchy box and click Create Empty. An empty object is an object that only has a transform. It's useful for marking points or storing other objects underneath them to group them together into one class. We're going to use this to store every object in our environment, so I'm going to go ahead and name this environment. Also, just as a bit of housekeeping, I like to set these empty objects that I use for organization to 0, 0, 0, so I always know where to find them in the game world. In the hierarchy, you can parent and child objects, meaning that if you manipulate a parent, the same effects will happen to the child. So I'm going to drag the directional light and release it on top of the environment, which will parent it to it. You can now see our environment has a little drop-down arrow, and the directional light is below it and slightly indented, indicating that it is a child of environment. If you disable a parent, it disables every child within it. If you move a parent, it moves every child within it. Same with rotation and scale. The main camera we're going to leave outside of the environment because we're going to want to attach it to our player later on. To create an object that's automatically a child of something else, you right-click on that object, go down to Create, wherever it is, and in our case, we want a plane, just to symbolize the ground. So if you hover over 3D object, it'll show you another list, and let's select plane. Most of the 3D objects out of the box in Unity, when you create them, will have 4 things on them. A transform, which just lets them exist in the 3D space. A mesh filter, which takes in data, essentially, so it knows what mesh is trying to render. A mesh renderer, which actually takes that data and displays it in the world. And a mesh collider, which is used in physics. Some of the other objects will have box or sphere colliders, but a mesh collider normally works for any object. You can name it whatever you want, but I'm going to call it ground because that's what we're using it for. Now from here, you have to actually think about design. One of the luxuries of having a 3D space is also the drawbacks, because in a 2D world, everything is flat. You layer things on top of each other, and that's pretty much all of the design work that you have to do. When you have 3 dimensions, you have to worry about angles, and everything gets much more confusing. Up here, we have an axis tool, which shows you the current rotation that you're looking at in the game world, as well as whether or not you're looking at it from a perspective or orthographic position. Since I want to make a 2D side scroller, I'd like the direction I'm facing to be forward, my right to be right, and up to be up. Meaning, I want to click on this gray arrow on the other side of Z. And now you see, it's aligned us so that we're looking directly along the Z axis. If we use this tool to drag our ground forward, you'll see it increases along the Z. If you pull it for us, it means it's decreasing along the Z. Same with X to the right and left, and Y on the up and down. If I were to go into isometric right now, this would essentially be a 2D world, something you're probably very familiar with in Python. This is two-dimensional. There is no Z-axis, and so it's X and Y. And that's what I said earlier about a lot of the math being completely the same. Also, if you want to move the camera around without rotating it, you hold down the middle mouse button and it'll show you this hand. That means you're dragging and you can move the camera to your liking. If you want to rotate without moving the camera, you hold down the right mouse button and you can freely drag from there. And remember, if you want to snap to any of the axes, just use this tool up here. Now that we have a ground, let's get something to represent our player. There's lots of different ways to do this, but what I like to do is to create an empty object, call it player, and then any logic we make for the player, movement or collision or anything like that, will go on this object. But things like graphics we can make separate so that the collision is not reliant on the graphics, because in my experience, that winds to some nasty bugs. As per usual, I like to put them to 0, 0, 0, but that'll change based on personal preference and the kind of project you're doing. Now let's go, right click, create another empty, and call that GFX, because this is where we'll be storing the graphics for our player. I feel like we should keep things fairly simple, so let's just go right click on GFX, hover over 3D objects, and select capsule. This is oftentimes used to represent a person, and it does the job fairly well. It's roughly the right hitbox size for it, and its rounded edges make it stand out from a usually blocky environment. You'll notice that our capsule here is halfway in the ground. That is because when objects spawn, they automatically put their origin point, in this case the center of our capsule, where at the center of wherever they spawned, in which case is GFX, which is 0, 0, 0, and it's attached to our player, which is 0, 0, 0. Now, an important thing to point out when working with parents and children is that if I move this player, to be somewhere else, the GFX child will still be 0, 0, 0, because that is its local position. That is where it is relative to its parent. If an object has no parent, this will be its world position, where it is local to the environment that it's currently in. But any children have their readout local to the space they are in. You'll see if I move the GFX slightly along, but then I remove it from the player parent, these values change to now represent the world stats. Also, shortcuts like Ctrl-Z work inside of the Unity editor, which is very good for undoing mistakes you don't want to make. But I should point out that it does not work with everything. Meaning if you're spamming Ctrl-Z and the change that you want to happen doesn't seem to be happening, you're probably undoing work that you didn't realize you were undoing. So if you know the fix, it's best to just type it in manually. In this case, we're going to make sure everything's parented over here and set everything back to 0, 0, 0. Now we have our capsule, but we don't want the logic for the capsule collider to be on the GFX because, like I said, we want those two to be independent. So if you click the three little ellipses over here on that every component has, you have lots of options, including copying the values, pasting the values, and various other things. But right now what we want to do is remove component. As you probably guessed, you can do pretty much the inverse of that by add component and typing in whatever you want in here. As a matter of fact, let's go up to player and do that right now. This is our player object. This is where we want all of the collision, all of the physics, and all of the logic for our player to be, so that this is what the game really mainly interacts with. Anything below this will pretty much just be taken care of by any logic that we put on the player. And I know it seems a little silly because we just removed it from the capsule, but let's add component and type capsule in here, and you'll see the results start to pop up, and add a capsule collider. As you can see, hopefully on your screen, a thin green line will have been created around the object, but at the moment, it's very hard to see, and there's two reasons for that. One is that it created the default collider, which I believe is just a sphere, meaning the only part of it we can see peeking through our other object is the green radius around the center of it. And two, it's that our environment is currently a stark, kind of difficult to look at white, which we will change in a second. But first things first, let's make this collider the size of our actual capsule. Go over here, we want the center to be at 0, 0, 0, but we want the height to be 2, and we can leave the radius at 0.5 because that's the default radius of things in Unity. They are 1 unit wide, meaning they have a radius of 0.5. And now hopefully you'll see a green wire mesh surrounding your capsule. Almost all of the things in scene view can be toggled off from this sphere up here. If you just click it once, pretty much everything disappears, although at the moment all we have was the green outline. And if you click it back on, it'll re-enable everything. But if you want a more detailed breakdown, you can click the arrow and manipulate them one by one. Every time I try to mess with this, I end up disabling something and forgetting that I did so, and not being able to turn it back on without Googling for help, so I tend to just ignore this area. Now our player is still halfway in the ground, but we want the player logic, and I'll explain this later, to be at the very base of our player. You'll see our GFX is still zeroed out on the player, but that's what we want, because when you start to move these, working with code can sometimes be very weird, depending on if you're working with a parent or with a child. Same goes for rotation and scale, because if you make the scale weird on a parent, it'll affect the scale on any children, which gets really weird when you do animations that involve rotation. So for now, we want to leave the GFX at its vector 3.0, vector 3.0, and vector 3.1, and we want to grab the capsule and bring it 1 unit out of the ground. Meaning you should now see your capsule standing what appears to be on the ground, and if you click on the player, you'll see that the green selection is still in the ground. That is because these are separate objects, meaning we want to move the center 1 unit up as well. The very last thing we want to do is add a rigid body. Rigid bodies are what gives an object physics. If it is going to be moving using gravity, colliding with things, or being collided with, it is a good idea to use a rigid body. Now you'll notice, unlike our capsule collider, it doesn't have a checkbox to enable or disable it. That's because Unity does a lot of its math based on the physics system, and you can't have them enabling or disabling this freely. There is a way to do it, but if you ever want to disable a rigid body, just go down here and press is kinematic. That'll make it completely freeze, which of course we don't want, so I'm going to uncheck it. One last thing to do before we get into actual coding is that this is difficult to look at and difficult to tell what's going on. I want to give this world some color, and since we're working in a 3D game engine, we can do that without writing any code. In our project window, if you're still down here in the scenes folder, you can either click on this assets timeline right here or on the folder over here. These navigation sources are pretty much exactly the same. This should take you back to the assets folder, in which case you're going to right click, create, folder, and let's call it materials. Materials are essentially the textures that you put on objects in a Unity game world. They're called different things throughout different game engines, but if you say materials, people will know what you're talking about. Double click to go in the folder, right click, create, and let's create our first material. Now, I don't mind the ground being white, but I think the player should have a different color, just to make it obvious it's not some capsule just sitting in the middle of our world. If this is a material we're going to use exclusively for the player, we can call it player. However, if you want to be more general and just use it for testing, you can call it whatever color you want to use, like let's say green. I'm going to call it player, but it's up to you, as long as you remember your own organization system. With our material selected, it shows you all of its information over here in the inspector, which you can change to your heart's content, but most of this stuff is not useful 99% of the time. All that we want to do right now is grab this bar next to albedo, click on it once, and it'll give you a color wheel. Select whatever color you want the player to be. I'm thinking a seafoam green. click the X, and then you want to click on the material inside of the folder and drag it into your scene. You'll see that whatever object you're currently hovering over, as long as it has a mesh renderer, will be changed that color. But the effect only takes place until you let go of your mouse. So I'm going to release my mouse over the player, and now the player is this color. If you change it in the inspector, it'll change in real time in the scene, which is very useful. Many of the changes you do inside of the Unity inspector will update in real time inside of the scene. And again, if you do that in play mode, it will be reverted after you exit play mode. Speaking of which, if I press play, you'll see we have a turquoise bean sitting on a white square and nothing is happening. So let's get to creating some player controls. I'm going to exit play mode, click on our player, and click add component. Now, we don't have any components to control our player, so if I were to type in something along the lines of player controller, you'll see that nothing pops up except for an option for a new script. If you type in a component that doesn't exist, Unity will automatically prompt you to create a new script, which is very handy for creating scripts on objects that need it. If I click new script, it will take me to a confirmation screen, and I press create and add. Unity will do a little of compilation, and after it reloads, you'll be able to access your script. Now, if Unity set itself up correctly, you should be able to double-click on this grayed out box where it says Player Controller, and it should load your IDE. However, if this isn't happening for you, or your computer opens something weird like Notepad, you need to go to Edit, Preferences, and External Tools. In here, you'll see lots of options, but the one we need right now is External Script Editor. If you click this drop down, hopefully you'll see your IDE that you installed. I'm using Visual Studio 2022, but you can also see the other versions of it that I have installed. If you can't find it in here, click Browse and find the file location in your files. But I'm good with Visual Studio 2022, so I'm going to leave that as is, and we're going to go back into the IDE. Now the question is, how do we want to control our player? You can feel free to take notes on this kind of thing for a brainstorming session in an external tool like Notepad, or you can just use comments in the IDE. So I would like the player to be controlled via the W, A, S, and D keys. Although really we're not going to use the S key for anything because this is a side scroller. And we're going to want him to be able to move left, right, and jump. Now if you're creating some Mario game, you could have some double jump, but I want them to be only able to jump once per touch of the ground. And these three parameters should be most of our basic controls. So first things first is actually getting input from the player. Unity uses its own input system, which you can access by typing input. This class is all of the inputs that you can make from the player side on the Unity engine. Of course, if you have information coming from external scripts or sensors or Arduinos or anything like that, that'll mostly use their own IDE and languages. But for inside of Unity, keyboard or mouse input, you're going to start with the word input. And then from here, since you're using a keyboard, you can either do get key, which will let you type in a specific key code, which is decent for quick testing. However, Unity has a more modular system called buttons. You can see here, if you type get button, you have an option for get button up, get button down, and various other things. Buttons are something you define inside of Unity, and Unity comes with a preset defined buttons that can be mapped to different things. Now, most of these are actually functions that Unity has set up for us that return the value we need if true, and usually some way to indicate if it's false. As you can see right here, this returns a bool. So if I were to do just get button and then type in some button code, for example, I think we have jump, this would return true if the jump button is being pressed and false if the jump button is not. Now to shed a little more light on that, I'll go back into the inspector real quick, go over to Edit, project settings and find input manager. And I'll drag that up here so it's a bit easier to see. And you'll see a couple of text bubbles and also a drop down that says axes. If you drop this down, these are all of our buttons. You can see right here is jump, and it is bound to joystick button 3, which of course doesn't mean anything when you're using a keyboard. Now if you go in here and type something like space, and if Unity doesn't automatically reject it after you place it, that means that the space key is now bound to the jump button. The name is what you need to remember, because the name is what you have to type word for word, letter for letter inside of these quotation marks. This is how Unity references their buttons. If I put this inside of an if statement real quick, and since this returns a bool, we don't actually need to put any equivocation here, but just for the sake of it, I'm going to put equals true. We can check to see if it's actually recognizing the button. To do that, we're going to use something I mentioned earlier, being Unity's debug console. So we type debug to access the console.log, which will just give a normal text bubble instead of an error or a message or anything like that. Then we're going to open parentheses. Then inside of these parentheses, we're going to put our message. I usually just do something simple, typically just an exclamation mark, but for today we're going to use hi. End it with a semicolon because we are in an object-oriented language. And then if we save this, and remember to save it, because if you don't save your script, Unity will not compile it and your changes will not show themselves. And if we go back into Unity, sometimes when you go back into Unity after editing a script, it'll take a moment to recompile the scripts. Right now, it seemed to do it quickly enough because we only have one script in the project. If you go over to the console and it's not showing any errors, that usually means you set things up correctly. And so if you press play to test it, and if we press space, you can see there in our console, we got hundreds of messages, or 101 to be exact, of hi. And you can see if I hold the button down, the log gets flooded with these messages. We'll leave play mode real quick. And as you can see, the messages in the console remain outside of play mode, which is useful for debugging because if you double click on a message, it'll take you to the portion of your code that spat out that message, which I personally think is one of the most useful features that Unity has. The reason it gave us hundreds of messages is because update is called once per frame. And in a very simple scene like this, we're probably getting thousands of frames a second, meaning that for the quarter of the second that I pressed down the space bar, this was reading as true every frame and it was printing out this message every frame. But what if we only wanted to say hi every time we press down the space bar and not if we hold it? You would go into here and change this to get button down. And again, IntelliSense is very useful. If you just start from the beginning, it'll give you that option as autofill. Of course, I selected get button up, which is not what I wanted, but it does essentially the same thing in this case because now when you press the button and hold it down, it won't do anything. However, when you release the key or the button comes up, that will display our message. We go back into Unity, and as you can see, it was recompiling our scripts. I don't want 999 plus messages of hi because I won't be able to see our new one. So you press this clear button. Also, if you press this little drop down arrow, you can set it up to clear whenever you build the project, whenever you play the scene, or recompile. At the moment, I have all of them selected, but it's all just personal preference because you can clear just by pressing this button. If we play again, and I press down the space bar, nothing happens, and you could probably hear it because of my mechanical keyboard, but when I release it, the message hi pops up in our console. And every time I press it, and every time I release it, it says hi. So now that you understand more of how the input manager and debug console works, let's get to actually creating these controls. And I know I just explained buttons for the last 10 minutes, but we don't actually want to use buttons just yet. So we're going to comment this part out, which you can do by selecting all of it and pressing this button up here to comment everything out, because we'll use that later when we want to use our jump code. What we want to use for movement is another input that Unity has called axes, or axes depending on how you want to pronounce it. It's another thing that is accessed by going input.getAxis. In here you have getAxis and getAxisRaw. Unity automatically does some lerping inside of these values. GetAxisRaw will always return a 0 or a 1 based on whether or not you're pressing down certain keys. GetAxis will do some lerping between 0 and 1, giving you a smoother feel. Generally speaking, for snappy controls, you'd want to use getAxisRaw. As you can see back here in Unity, the horizontal and vertical axes are set up already in our axis manager. And those are the ones we want to use because the horizontal axis is automatically bound to not only A and D on the keyboard, but also the left and right arrow key, as well as the vertical axis being bound to W, S, up, and down. Meaning, if we open parentheses and type horizontal, so we have our reference to our axis, but we have nothing to do with it yet. This is a raw data value. So let's store this inside of a variable. We're going to want it to be a float because Unity likes doing math with floats. We'll call it something like x input because this will be our x-axis movement, and set it equal to that. Now if we were to reference x input, it would give us whatever this value is. We're going to want to do the same thing for the y input. So if we copy and paste, you'll see we get a red underline because we've tried to define the same variable twice. Change u to y and change this to vertical. We now have our x and y inputs stored in variables. And just to confirm that this is working, we can set up some real simple controls. Let's move our player according to this raw data. Up if y is positive, down if y is negative, as well as left and right if x is negative or positive. But to do that, we're going to need to reference our player. Now, there's two ways to go about doing that. First one is you go up here and you create a reference. We're going to want it to be public, just because making things private when they don't need to be tends to make it harder to access values when you need them. If you really want to make things as private as possible, you can go through at the end of the project and try making things private and see what does and does not break. We're going to want to make it a game object because that's how you reference things inside of the Unity scene. You can also reference things in your asset folder, but that don't currently exist inside of the Unity scene by calling game object. And let's call it player. If you want to be something more specific, you can type player obj or any other modifier, depending on your coding practices. We'll go back down to our code and type player obj, and you can see IntelliSense is trying to do most of the work for us. .transform.translate. Translate is just how you move an object by X number of world units. It does not take into account physics or anything like that. It just moves an object. We want to move this object up by the Y input because Y will be -1 if we're holding down and 1 if we're holding up, and right by the X input because it'll go to the right if we're holding down right and to the left if we're holding down left. And the way most of those operations go in Unity is you name the vector you want to move along. In this case, we'll do vector3.up, which is just a vector that has 0 for the X, 1 for the Y, and 0 for the Z, which you can see it writing right here. Multiply that by our Y input. And then, since we're doing this inside of update and it's being called every frame, we're going to want to multiply by time.delta-time. If you're making some transform per frame and you're potentially doing something every frame, if you want to remain consistent regardless of the frame rates of your person's computer, you want to usually multiply by time.delta-time. Time.delta-time is the length since your computer has last drawn the frame, meaning this will be proportionally larger the shorter your frame rate is. If we put a semicolon there and we go back into Unity, at first nothing would happen, and if we were to press play right now, it wouldn't work because over in our player controller script, the player obj is currently nothing. So what we want to do is grab our player from the hierarchy over here, and drop it in this slot. Now, if we press play and press either W or the up arrow, you'll see our capsule is trying to go up. The reason it's unsuccessful is because it currently has gravity. So every frame we're moving it up slightly, but gravity's bringing it back down, causing it to kind of just vibrate like that. If we turn off use gravity real quick, and you can see also our bean fell over, but if we turn off use gravity and hold up, our bean will go up along its own y-axis because transform is local. It will not use the world scale. So you can see our bean floating off to the right here like some majestic jelly bean. So we'll want to leave play mode, and as you can see from that, our input is working, but that's obviously not the control scheme we want for the actual game. So let's head back over to Visual Studio and start making our actual controls. I'd like this to be physics-based because I find that's the easiest control scheme to make, to have fluid-looking movement, and to have it not be too difficult to code. However, to do that, we're going to have to reference the rigid body that is on our player. To do that, we'll go up to the top of our code again and create another reference, this time to a public rigid body, and you can call it something like RB. We'll get rid of this line of code because we don't need it anymore. So, the first way I showed you to reference something was to drag and drop it inside of the Unity inspector. However, there's another way to reference something if it's on the same game object that this script is on. To do that, we'll go up here to start, which as you can see right here is only called on the first frame of our application running. We'll reference RB and set it equal, and you can see again IntelliSense doing some of our work here, get component rigid body. This will get the component from the current game object, and another way of writing this would be game object with a small g dot get component. This is the exact same as this. The reason there's a difference between the two is because we could put a reference to any other game object in here and get the rigid body component on that game object. However, if you don't put any reference, Unity methods will automatically try to do it on this game object. So now that it's referenced in start, we can go down here and go rb dot add relative force. Relative force uses the local rotation of an object, whereas just add force uses the world rotations. But since we want this to be relative to the position of the player, we'll just use add relative force. This is going to be for our left and right movement, so inside of parentheses we'll do vector3 dot right multiply that by our x input, and then multiply that by time dot delta time. Now if we save that and go back into Unity, first we want to come over here to our player object, over to our rigid body, and hit this little drop down arrow next to constraints. If we just ran the script as is, our bean would probably tip over, and we don't want to do that. So let's freeze rotation along the X, Y, and Z. That way it'll push our character along, but it won't rotate him. You'll see you can also freeze the position if you so desire, but I have no need to do that right now. Now, if we press play and hold down A or D, practically nothing happens, although you can see the value changing very minutely up here. That is because time.delta time is usually a very small value, meaning using it in multiplication makes whatever the result of this is to be a very small value. So normally what you do in circumstances like this is you create another variable. In this case, I'm going to make it a public float. We'll call it move speed. And then we want to multiply by move speed. You see Unity will have created a move speed item for us here in our player controller script. I'm going to set that to something like 500 just to make sure it's working right out of the gate. I'll press play again. And as you can see, we're moving to the left and right. If I hold down D, I go to the right. If I hold down A, I go to the left. You'll notice, however, our player is very slippery. It's like he's moving around on ice. If I hold down A, he gains momentum, but when I release it, he continues to slide. And you can also see the physics in action there as he slid off of the platform. There's several ways to counteract this kind of fluid motion and have him stop on a dime. But the way I like to do it is set a limit for the velocity that the rigid body can be and have very high acceleration, meaning that essentially when you start holding down the inputs, he reaches his top speed very quickly and he won't exceed it. To do that, we want to head back into Unity, and we're going to use an if statement for that. Type if rb.velocity.x is greater than, and we'll do something along the lines of 8. And we'll move this inside of the brackets. And now we actually want to put an exclamation mark here, because the exclamation mark, when being used in the equivalency statements, is used for negating. If we put an exclamation mark here, this will mean if the rigid body velocity.x, meaning the x-axis velocity, is not greater than 8, it will not add a force. Now, the way the velocity works in the rigid body is if it's moving to the right, it's positive, and if it's moving to the left, it's negative. Meaning that this constraint would work when moving to the right, but it would not work when moving to the left. So we want to put in one more modifier, which is math f, which is Unity's library for mathematic equations, dot ABS for absolute value, essentially making whatever value is inside of these brackets always positive. And I think I'll actually change this is not greater than to a less than, just to make it a little less messy. If we go back into Unity, still have our player move speed at something crazy high like 5,000, and press play, you'll see he's still sliding. And that's because it's constraining fine, but it's not slowing down. Simple solution here is to just add a couple units of drag. Now you can see when I release the key, he comes to a nice stop. While we're here, I'm going to expand this platform a little bit, just so we're not as much in risk of falling off of the edge. Now then, we can move left and right, but what about jumping? Back in Visual Studio, if you still have the code from earlier, you can uncomment our button get up jump logic, which is most of the logic done already. I'll clean it up a little bit. For example, we don't need this equal to equal true. And it should probably be get button down instead of get button up. Now, instead of debugging the word high, we want to do rigid body dot add relative force vector 3 dot up. Now, for this, we don't want to use X input or Y input because this isn't something we're going to be doing every frame. A jump is a single instance, in most cases a single frame, so we want to use a solid value, something along the lines of, say, 10,000. We don't need time.delta time because, again, the plan is to have this just be a single frame. And we don't need move speed either. That should be a fairly simple jumping mechanic done already. If we go back into Unity, you can see we get launched into the sky. And if we check on our player, you can see he's coming back down, but he's not doing so very quickly because of the amount of drag that we gave him. We'll leave play mode and head back into Visual Studio and change this because perhaps 10,000 was a little much. Change that to something like 100 to see how that fares. Head back into Unity, press play again. And now you can see we have a very weak, small jump. Lots of coding, especially when making hard-coded values like this, is definitely guess and check. So this is a very normal part of the process. We'll put that to something like 500, which will hopefully give us something of a suitable jump. And as you can see, we jump and we somewhat slowly float back down. Now, the issue is, this happens every time we press down the spacebar, meaning I can do it indefinitely. This is not what I want for the project, although if it's what you want, feel free to leave it as is. To change this, we're going to have to make sure whether or not the player is grounded, and here comes into effect why I wanted the player position to be at the base of the capsule. If you select the player, and it shows you your cursor in the middle of the player, make sure this is set on pivot, and hopefully it'll be at the bottom of the player now. Head back over to Visual Studio, and let's set up another variable. We'll make it a public bool, and call it grounded. This bool will essentially represent whether or not our character is currently touching the ground. Again, there's lots of different ways to do this, but a simple one for a case like this is to use Unity's collision system. Like update and start, Unity has lots of built-in functions, and the one we're going to be using right now is going to be onCollisionEnter. This collision parameter right here is the data for whatever collider this object hits. So for example, if this player were moving along and he hit the ground, this would trigger because it was onCollisionEnter with another collider, and this would be the collider for this plane right here. I'll move our player back to 0 because that could get confusing. So onCollisionEnter, or when our player hits the ground, we want to set grounded equal to true. And I butchered the placement right there, so I'll fix that real quick. Now, when we hit the ground, grounded will be set equal to true, but when we leave the ground, we need grounded to be set equal to false, which is essentially the same process in reverse. We type onCollisionExit, grounded equal to false. Sometimes IntelliSense will just write what you need for you. The last step is to check. Inside of our if statement, we put 2 ampersands to do the and condition. Grounded equal to true. This way, we'll only jump if we press the jump button and we're grounded, which again will be false when we leave the ground and true when we touch it. As you can see, or probably hear from me spamming the spacebar, I can no longer spam double jump, and when we touch the ground, the grounded bool over here becomes true. And when I jump, it becomes false. Now, we can move around this world, but unfortunately we can move outside the view of our camera, and that's because the camera is not currently following us. So we're going to create a script that attaches the camera to the player. To do that, click on the camera, and like we did for the player, hit add component, and type something like camera follow. Of course, the names for the scripts really only matter so that you remember which script is which. Whatever name you want to pick for it is fine. Hit enter and hit create and add. Double click on it to open up in Visual Studio, and in here we're going to need to declare some variables too. We'll need a reference to the player because that's the object we're following. Of course, we don't need to reference the game object, just need to reference the transform because the only thing we care about is the position of the player. So we do public transform. Sometimes Unity will get excited and put in the wrong thing for you. Transform. And we'll do player position for our variable name. Now if we go down to update, we want to set the camera's position equal to the player's position plus some offset so that we are looking at the player instead of being directly at the player's feet. So to reference the camera's current position, we can either do GameObject.transform.position, or we can simply just do transform.position because without the game object here, Unity will know we're talking about this game object. And we can set it equal to player position plus some new vector 3. This vector 3 will be our offset. We want it to be lined up on the X and the Y, but I'd say we want it to be about 10 units back on the Z. Now if we save this and go back into Unity, it won't actually work because we haven't referenced the player's position, and you can see that's what our debug console is being flooded with. Over here we have a blank transform object for player pause, so if we grab player and put it in there and then hit play, the camera now follows along. Of course, with this being a plane and it only being drawn on one side, it makes the graphics a little weird, but you get the general idea. Perhaps we should even move the camera up a little bit along the y-axis so we have more of a top-down view. To do that, simply change the y value to something like 5, and then head back into Unity to see your changes. That's not exactly what I wanted, but it is substantially better. I think I'll settle on something like 2 or 2.5. Now, an important thing to note is that if you're making a float, that is to say a decimal value inside of code, you have to put an F after that value so that Unity recognizes it as a float instead of some mistyped value. That's more like it. Now, a couple things to make it look nicer. I think we should be able to jump a bit higher, and I also think that we should come down a bit quicker. For the first one, it's fairly simple. We can go back into our player controller and up our jump value. I'll make it something about 1500 instead of 500, and of course we can change that if it's too high. And to go down quicker, we can simply check if we are grounded, or more accurately, if we are not grounded with the exclamation mark in front of it. We can just add a force, a relative force that is, to our rigid body. We'll do it along vector 3 dot down, which is just the inverse of vector 3 dot up from earlier. We want to do it something nice, like, for example, let's just use 10. That's essentially doubling the force of gravity. And since we're doing it per frame, we want to make it time.delta time. Now, since we're multiplying by time.delta time, 10 will probably be far too small of a value to actually notice, but let's test it out. As you can see, we jump higher, but we don't fall any substantially quicker. So we'll go back in, change you to about 1,000, which will probably be too large. And you can see we are now falling faster. I still think we could actually stand to fall a bit quicker. So let's change you to 1500 like we have for our jump. And I think that's a much nicer looking jump. You can see it still doesn't look completely smooth, and that's because that's usually what you get when you have a lot of drag on an object, which is what we're using to stop. But for quick and dirty controls, it's not a bad scheme. Now, it wouldn't be a platformer without things to jump on, so let's add a couple more cubes into this environment. Right-click on Environment, hover over 3D Object, and select Cube. Of course, if you want to use some other obstacle, that's fine, but cubes are generally the easiest because of their simple colliders. I think the cubes could stand to have a bit of color though, so we'll leave play mode, go into project, go into our materials folder we made earlier, and make a material for the obstacles. Like we did earlier, you can either make it a plain color, or you can call it something specific for the obstacle. I'm going to call it OBS, and I'm going to give it a gray. It's not harmful, but it's different from the ground. Again, if you press play, you can now see a bit clearer. Something I noticed just now while testing, if you run into this cube and move away from it, you lose your grounded status and lose the ability to jump. That's because when you're touching this cube, it's triggering on collision enter, and when you're leaving it, it's triggering on collision exit, like you just walked off of a platform. However, we should of course still be able to jump because we're standing on this flat surface. So if we leave play mode and head back into Unity, there's one more on collision we need to add here, which would be on collision stay. This basically, instead of checking for entering contact or leaving contact with an obstacle, checks if you're maintaining contact. And of course, if we're doing that, we want grounded to be true. So if we save that and head back into Unity, you see that even if we brush up against things, we'll always have the ability to jump if we're standing on a flat surface. From here, all we really need is a gameplay direction, so let's grab a couple cubes and spread it around the environment. You can do this however much you like, but I like the idea of a tower climbing game, so I'll make them spread out, generally easy when you're going up, but get harder and harder as you get to the top. There we go. As you can see, I placed cubes in something of a confusing pattern to jump along. And to be honest, as it is right now, you probably won't be able to complete this with the settings you have set up. Either the jump or the bean will be too large, or any number of problems that might happen. As you can see right here, I can't jump high enough to make it up onto this platform. And that's all a part of the creative process, just debugging. If I make our jump strength a little bit higher, change it to something like 2500, I can now fairly easily, perhaps even a little excessively, complete this obstacle course. The largest challenge is honestly losing sight of the blocks as I'm falling back down. But as you can see, that was pretty close to being a game. Now, there's lots of areas that you could go into here. You can make it more polished. You can obviously hone out these controls, levels, menus, all of the stuff like that that takes lots and lots of work and several more hours if I wanted to actually cover. So for this tutorial, I'm going to leave it right here. Now, if you'd like to see how I personally would further this project, you can let me know down in the comment, and I'll definitely make more of these tutorials over on my channel. I typically stick to more devlog type things where it's less explanatory and more entertainment, while still guiding you through the journey of my game creation process. However, again, if you'd like more long-form tutorials and like the stuff I made, let me know and I'll consider making it a series. While I have you here, I have to self-promote a little bit.
Alright, you guys, that is going to do it for this video. I'm just kidding. Go ahead, George.
I do recommend going and checking out my channel in my completely non-biased manner, but if you're only interested in Python tutorials, you won't find any of those over there, so I guess there's no need in that case. Regardless, I hope you enjoyed, and I hope this was informative at the very least, and I'll give this back over to Lemaster Tech if he has any closing words.
Okay, so that is going to do it for this video. A massive thank you again to Southpaw Development, my younger brother George. We all really appreciate you coming on and sharing your Unity expertise. If you guys are interested in us pursuing more stuff into game development, be sure to let me know in the comments below, as well as check out Southpaw Development's channel. Be sure to check out his channel. Let me know in the comments below that you'd like to see more stuff like that. If you have any comments on this, I did this tutorial as well, and I'd be happy to pass them on to my brother as well. So feel free to ask your questions in the comments below as well. Thank you to everyone who stuck around for the whole video. Really appreciate you guys watching this. Massive thank you to our Patreon supporters. Thank you to everyone who subscribes on YouTube. Until next time, good luck with your projects. Thanks. Bye.